Welcome to our exam questions. We're going to be going through GCSE questions and A-level questions in our series, and today we're focused on geometric sequence, which is from the Edexcel November 23 paper. It's from paper 1 and it's question 22. So I want you to pause the video, have a go first, and we will put the question properly and link it down below. And once you've done that, I'm going to go through it with you. Let us know if you got it right, and like the video if you want to see more of these. So firstly, what are we looking at? So we know the second term of the geometric sequence is 3 plus 2 root 2. We know the third term of a geometric sequence is 13 plus 9 root 2. And we want to find r in the form of whatever. So, a little bit useless to do this question unless we know what a geometric sequence is. So let's start there. So we should know that a geometric sequence follows this pattern. It's A, where A is the first term of the sequence. And then AR, so it's multiplying by something. And the key thing to remember with geometric sequence, it's always multiplying by the same thing. So with arithmetic sequences, you're adding the same thing every time. Geometric, you're timesing by the same thing every time. So a good example of a geometric sequence would be 2, 4, 8, 16, 32. 2 being the first term, and 2 also being the common ratio. And now we can apply this to the question. So, the second term and the third term. And we want to get r. So quite simply, we know that if we're multiplying by r each time, then to get r, we can do the third term divide the second term. And then we just substitute that in. So we would have 3 plus 2 root 2 over 13 plus 9 root 2. Cool, we're done, right? Oh, that's only 2 marks. We need to read the question. Find r in the form a plus root b. Most of you will not get the grade you want because you don't read the question. You're going to panic and try to skip it because it looks like it's done. And if you're silly as me, you're going to write them the wrong way around as well. So let's just correct that. And maybe actually do the third one over the second one. But as you must have just seen there, by taking your time, you'll be able to spot your mistakes. So, how do we get this in the form of this? We need to rationalize the denominator. So the reason why that works is because right now, this denominator is irrational. So you want to rationalize it, which will mean that you can then simplify the denominator. So it'll either be 1 or some sort of multiple so you can cancel out the end. So to rationalize the denominator, you need the congruent pairing of 3 plus 2 root 2. Now, it's easier to just remember what it's going to be rather than explaining it, but I will do both. So, the congruent of this is 3 minus 2 root 2. Also, guess how many pens I can fit in one hand. So, this works because when we multiply these two terms and these two terms, they're both going to be non-surds, and the middle term will cancel out. And that's based off the fact that if we look at the difference of 2 squares, when you expand this, it gives you a squared minus b squared. So that middle term disappears. So you're multiplying this by the denominator, and this one's going to be 13 minus 9 root 2. Have a think while I write this out. And the answer is not quite, because we don't want to change the answer, we just want to manipulate it. Therefore, to make sure this stays unchanged, the numerator needs to be the same as the denominator, such that this is equal to 1. Therefore, we're not actually changing anything. And now we can just go and expand this out. So 13 times 3 is 39. 13 times minus 2 root 2 is minus 26 root 2. We have 27 root 2. And that's going to give us minus 36. Denominator is 9, minus 2 times 2 is 4, root 2 times root 2 is 2, so that's minus 8. And the numerator is 3, plus root 2 and the denominator here is 1. And we don't need to write A is equal to B is equal to. This is plenty for our answer, and this would be 4 out of 4. Let me know what you thought of this in the comments, and we'll see you next week.